Good morning, everyone.
Morning, ma'am.
Good morning, ma'am.
Hello. Hello. Good morning, ma'am. சொல்லுங்க மேம் கேக்குது மேம். ஓகே மேம்.
Hello. 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 கெஸ்ட் வந்துட்டார்ல? என்ன நேம்ல இருப்பாரு சார்? ஸ்டார்ட் பண்ண சொல்லிட்டாங்களா? மேம் ரெடியா இருக்காங்களா? அவங்க தானே
தமிழ் ஸ்டார்ட் பண்ணுங்க.
ஓகே மேம். ஸ்பீக்கர் ஜாயின் பண்ணிட்டாரான்னு ஒரே ஒரு வாட்டி செக் பண்ணி
கன்ஃபார்ம் பண்ணிக்கோ.
Okay, sir. Thank you, sir.
தமிழ் ஸ்டார்ட் பண்ணுங்க.
Okay, ma'am. Thank you. Good morning, everyone. We are glad to have you all in this wonderful event. On behalf of the Faculty of Allied Health Sciences and the management, I would like to extend our warmest welcome and good wishes. I request all the participants to be on mute throughout the session. At the end of the session, you can raise your questions. Today's webinar topic is on vaccination. Of the 80 plus known infectious agents pathogenic for humans, there are now more than 30 vaccines against 26 mainly viral and bacterial infections, and these greatly and prevent death after exposure to these agents. Vaccination protects humans from diseases. Particularly during this COVID crisis, every one of us should know she is the pillar of our strength. Yes, I would now like to invite our beloved principal, Dr. B. Kalpana Devi ma'am, to welcome our gatherings for this auspicious guest lecture.
Good morning, one and all. On behalf of Faculty of Allied Health Sciences, I take this opportunity in welcoming you all for this guest lecture on the topic Vaccination An Overview. I consider it as a great honor to welcome all the participants. First and foremost, I would take heartfelt gratitude to our Founder Chancellor, Thiru Dr. A.C. Shanmugam sir, our Honorable President Engineer ACS Arun Kumar sir, and our Honorable. I also extend my gratitude to our Vice Chancellor, Dr. Geeta Lakshmi ma'am, for her constant support. I also welcome our Director, Dr. Kalavati Victor, for this guest lecture. And now I take this as an opportunity to express my hearty welcome to the guest speaker of the day, Dr. S. Jagannathan, Assistant Research Officer from Pasteur Institute, Kunnur, who has consented for this guest lecture. Welcome, sir. Welcome to all the faculty members and students. I welcome you all once again. Hope that you will have a great time ahead. Thank you.
Thank you, ma'am. I now request Dr. Sendil Kumar sir from the Department of Medical Lab Technology to introduce our speaker of the day.
Good morning to all. It's my great privilege and pride to welcome our chief guest, Dr. S. Jagannathan sir, Assistant Research Officer, Pasteur Institute of India. He has done his PhD in microbiology from Orlear University, MBA from Periyar University, and MSc Molecular Biology in University of Madras. He has held several positions in various government sectors as JRF, SRF, in ICMR, ICAR, and DPT, and also worked in tissue culture and vaccine production centers. He has got 2 patent rights for his inventions. He has published more than 30 papers on various national and international journals. He has written 5 books in the field of immunology, nanotechnology, and biotechnology. He has been an editor in various journals. He is a research guide for many young researchers. He has guided 55 students in the field of MPhil, MTech, BTech, MSc, which include 2 PhD students as well. He has presented so many webinars, CME in Ministry of Home Affairs, Ministry of Family Welfare, and Ministry of Consumers in various government sectors, colleges and universities. He has received so many awards in many colleges and government sectors. It's a great honor for me to welcome you, sir, for this guest lecture on behalf of Faculty of Allied Health Sciences, Dr.M.G.R.E. Research, M.G.R. Educational and Research Institute. I extend my warm wishes and welcome you, sir. Thank you.
Thank you. Thank you, sir.
Thank you, Sendil sir. Great to know about your achievements, sir. Your experience and knowledge will definitely help our students to know better about vaccination. With great privilege,
Yes,
I would
yes.
love to welcome you for this guest lecture. Looking forward to gain knowledge. Kindly take over the session, sir. Thank you.
Thank you. Thank you. Once again, thanks to the management and the entire team who gave this opportunity. And also, I extend my thanks to my friend, Dr. Sumita, because of her only I was contact with Dr. Sendil Kumar. Today, I am going to speak about the vaccination overview. Whether my slides are clear now?
Sir, make it full screen, sir.
Okay. Just I'm starting one. Yes. Now it's you got
Yes, sir.
full
Yes,
clear.
sir.
Now?
Yes, sir, it is clear.
Okay. Good morning once again. One of all. Yeah. So my concept is vaccination. That means the vaccine, vaccination, and overview, and also it will going to cover the entire productions also. In your first slide, you can see the something that is called as a 1, 2, 3. 3 different images was there. One is the great Louis Pasteur. Yes, he was the first person development of vaccine against rabies in 1885, and also he was the director of Pasteur Institute of Paris. So because of his Dr. Louis Pasteur credentials only, our Pasteur Institute was started. So that's why that same emblem was there in another corner. And next is our Pasteur Institute traditional heritage buildings there. And also this is a heritage building as well as this is a typical building for rabies. So the structure of rabies is a bullet-shaped viruses. So that's why entire four corners in our block. This going for a bullet-shaped domes was there, and also you can see the sum of the vehicle that is leads to the vaccine, produced vaccine go for that. So there's a vaccine, vaccination and overview. I'm moving to my first slide. Okay, what is vaccine? It is a biological preparation. What is meant by biological? Biological, it can able to generate their offspring. It can able to digest its own itself. So that's a biological, like bacteria or viruses or human being as a, this is called a biological preparation. Once the preparation is completed, it's going to be administered through the various routes, through the injection or inhalation or oral. So once you are injected, once you are administered, it's going to stimulate our immunity system against the intended infectious agents. That's a vaccine. Use harmless variant of the pathogen. That's a biological. Harmless means, that means it's a harmful, it's called as a pathogenicity. Harmless variant of the pathogen. That means it is not a pathogen, it is a inactivator. So how it was going to developed by the process called as killed methodology or attenuated of microorganism, or sometimes is a laboratory generator, altered form of its toxin or one of its surface marker. So here surface marker means when the microbes like viruses or bacteria is going to present in our body to causing the diseases. So that surfaces is having some specific receptor or specific binding domain. Maybe in glycoprotein or lipoprotein or different kind of proteins there. Sometimes it's a spike in nature, or to be in glyco nature or lipid in nature. So like that. There is a surface marker also we may is a vaccine component. Okay. Ability of, okay, how the vaccine going to give to some good benefit to us. That means ability of a living being, is a human, animal or any microorganism, to resist and protect itself from the harmful effects of an offending microorganism or a toxin. Harmful micro effects against that particular microbes is going to enter our body. And also the efficiency. The efficiency of the immune system lies in the ability. That means once our vaccine was entered our body, that immunity be in a particular level, it's going there. And sometimes after the vaccination, it's going for enhancing by the vaccine, and also without causing the harm. Yes, that vaccine, it's not giving the problem. It's not giving the toxicity. It's not cause any kind of problem. That's why without causing harm to the host, as well as it is not underwent for the any cell damages or the tissue damages. The vaccine act by allowing immune system. Okay, it's a specific, it is something specific based. If you are going to vaccination against something called as a BCG, bacillus calmette, during our childbirth or the day of 1 to 3. So once vaccinated, there is a development of antibodies. There is a specific antibodies, like it's an IgG or 99%. That IgG antibody is a specific. It is going to keep in some memory. It was kept in some memory cells. So that memory cell, if the baby is going to expose to the, again going to get the BCG, that means Mycobacterium tuberculosis infection, that bacilli is going to enter that already that baby having that antibody specific against BCG. So BCG antibody is an incoming Mycobacterium tuberculosis going for the invading or neutralization. So that's why it's stated that it recognizes and memorizes the harmful viruses or toxins. That is a vaccine anti-system. Next is a booster doses. Why we need a booster doses? Currently, we all peoples are having a lot of questions. Sir, I vaccinated on Covaxin or Covishield. When I am going to the booster doses, whether I will start now or I am waiting for another 6 weeks, or I am going for wait for 84 days or this thing. So why this kind of things? Booster doses means once you have the vaccination, there is a development of antibodies. It will be in particular level, but above your regular needed. Once you are going for the booster doses, to enhancing, to upgrade it, to uplift the IgG. So that's why the booster dose is more important. Next, some of the factors against vaccine. That is a major contribution But vaccines have made in saving countless lives around the world. Yes, it's saving countless lives. Lot of lives were saved because of that vaccination. Every year, up to 4.5 million children's lives are saved by the immunization. That is a statistic from World Health Organization. Every year, up to 4.5 million. It is not a fixed value. It's going for yearly by yearly. It's going for more than million and million hours. Going for it is enhancing. It is improved that because of the vaccination. And the next is vaccination is proven and one of the most cost-effective child survival intervention. Cost-effective means it can be affordable by the government. It should be vaccinated to the vaccinated to the people is a free of cost. That's a cost-effective. And also for the vaccination, each and every country they're having that own immunization program. Having the own immunization program based on the geographical distribution of the diseases. Some countries having some peculiar diseases. For example, African countries they're having the Japanese encephalitis. In case of UAE based, there are influenzas more, and the United Nations more influenza there. Kind of country they have their own immunization program because the top most is give the same kind of vaccines to the all countries there. So that's why the peculiar vaccination program. And also, in particular, to the targeted beneficiaries. Why? What is meant by UIP? That is a Universal Immunization Program. That Universal Immunization Program that was covered in India. Previously, it was called as EPI, Expanded Program for Immunization. So that program now is renamed as a UIP, Universal Immunization Program. In this regard, there as well as the new infant and the children, so they are going for the vaccinated on particular diseases like around BCG, start from the BCG, measles, mumps, rubella, JE, and hemophilia influenza and polio, rota vaccines. So these are some risk, and also for in pregnancy mother, they're also going for vaccinated with this one called as a tetanus. There are 27 causative agents against which vaccines are available, and many more agents are targeted for the development of vaccine. So currently we have different kind of diseases identified, but only successful around 27 causative agents vaccines are available. That means it's a good vaccine. There is no count for COVID also here. I could not put a count now. Because all 27 vaccine, it took a minimum of 5 years to the development. So normally vaccine development will take a long time. Yeah, you can get information later. So that's why there is a 27 causative agents against that which vaccines are available, and many more agents are now currently targeted for the development phases. But vaccines are not only for preventing the infectious disease, and also some help the body to fight range of illness by activating our immune system towards recognize and attack the diseases. Activate our immune system. Yes, you are going for activated our immune system. So that's why currently a lot of advertisements are came. So we have something which is called as an immunity booster, and this kind of food it's going for immunity booster. Zinc also going to immunity booster, and this one, and vitamin C also immunity booster. So a lot of immunity boosters there, but immunity booster is in as such condition. But vaccine having the only capacity is going for the activating the immune system against the specific function. Okay. There is a vaccine. Okay, some of the vaccine, it is not a single, it is a compartmentalized, and also something is a contain different kind of material. So that contains one thing, that is a disease-causing organism. That means it's a microbes, either is a toxin or it's a whole microbes. And next is a blueprint for the making of tiny fragments. Blueprint means so entire microbes is having some genetical material. One is called as it's an DNA or RNA. So that blueprint based also act as a vaccine candidate as an adjuvant. And also it contains other ingredients to keep the vaccine. It is in safe as effective condition. So it also contain other ingredients to keep the vaccine. It is in a safe as well as in effective conditions. Each vaccine component serves as a specific purpose, and each ingredient is tested in the manufacturing processes. During the manufacturing process, each having that IPQC, in-process quality control test is there. So during the process, all the ingredients are tested as per the guidelines by the national regulatories, either it's an Indian pharmacopoeia or US pharmacopoeia or Japan pharmacopoeia. Based on that regulatory norms, mandatory rules, that the entire vaccine ingredients are going to the tester. And also it meet the safety. What are that ingredients? One is antigen, already I told, it's a disease causing organism, whole microbes, or blueprint. And a stabilizer. Why we need a stabilizer? Or to the vaccine. So while vaccine, it is not in single paces there. That having there is a liquid-based vaccine, or is in a solid-based or semi-solid-based vaccine. So that kind of vaccine, we are going to keep them further to check the vaccine stability. To check the vaccine, it is an accelerated condition. If we are going to keep a vaccine in a +4 degree temperature in our fridge, or -21 degree temperature in our freezer, or -80 temperature for the long-term storage, or 37 degree and also ambient temperature, during the various temperature period, that vaccine antigenicity, that vaccine protein, it should not it should not lose that regular specific activity. So because of, we added a stabilizer. So for example, stabilizer is a human albumin or as a maltose. These are the acting as a stabilizer. And the surfactants. The role of surfactants here, especially for the viral vaccine. Liquid vaccine. So the liquid surfactant means towards the inner surface of the vaccine vial. Something is going to, in a biofilm formation. Biofilm. I thought all the people knows about biofilm. We have seen in our toilet and bathrooms. Sometimes it was and the entire thing is going for stagnant there. It leads to some formations being some sticky in nature, as well as going for sticky is the formation, because of it's going to bind on the surfaces. Same kind of action is going to happen inside the vaccine vial. If it has happened, those content of the vaccine, liquid vaccine, is going to contact with the inner surface of the vials, is going to the problem. That's why we added with this something as a surfactant to avoid the collider between inner surfaces as well as liquid vaccine. And the next is preservative. The role of preservative is to keep the vaccine in as condition to avoid the contamination. Sometimes, if a vaccine vial is a 10 doses there, that means it's a 5 ml vaccine, or 0.5 ml is a dose. Once they opened that, if that particular patients are not there, or the person is not there, means it's open and kept in again, back to the fridges. So there is a possible to that towards some making up to the contamination 0.99%. So that kind of things, it should not be made with our original vaccine. So that's why we had it with the preservative. Thiomersal is some example. And the next, adjuvant. Enhancement like a human, that is called as calcium, sodium, that means the calcium chloride, something but is the M59 sodium hydroxide and sodium hydrogen. Various kind of adjuvant is there. Going for adjuvancy, that means enhancement, much more antibody response during the booster doses. That's why they had it with the adjuvant. And as a final, diluent. So diluent means specifically for the freeze-dried vaccine. So the freeze-dried vaccine, they are filled in particular vials. After the filling, under the vacuum condition, it was going for, it is formed as a ice crystal. It's formed a small button-like structure under vacuum condition. As such, vacuum is going for sealing and crimping. Finally, that is going for given along with a diluent. That is called as either it is a 54 millimolar sodium chloride or it is in a water for injection. So that's appropriate. That is intended for the particular things. If you're going for the vaccination, the particular liquid freeze-dried vaccine, we may take the ampoule and cut the ampoule and take it in the diluent and directly inject that. It's going for properly mix it that, because of the inside it contain vacuum that. So these are some main component and also important component as a vaccine, like antigen, stabilizer, surfactants, preservatives, adjuvant, and diluent. Okay, now I'm on to the type of vaccine. So various type of vaccine, I'll give only in a few categories. One is live attenuated vaccines. It's an altered or weakened form of the microorganism which lacks virulence but retains the ability to create immunity against the diseases. For example, measles, mumps, rubella. And next is a varicella vaccine for the chickenpox. And next is a oral polio vaccine. At present, we are in the generation, we are not able to see this kind of children nowadays because that entire kind of it was caused by the poliomyelitis virus that was fully eradicated. I thought you were the people, those who were students there and your community people, you were helped more to the eradication of poliomyelitis through the mass vaccination campaign. Every year in the month of January and February, as per the guidelines from World Health Organization and also Indian Minister of Health and Family Welfare, we are in that conducting the mass vaccination against the pulse polio program. So those the kids, the age of the below the 5, they're going for the oral polio drops. Because of that the entire disease was eradicated in India. Actually, we reached in cases was on January 13th and 2011. This was happened at West Bengal. From 2011 to until December 2014. So immediately, there is no cases happened. The World Health Organization, they declared that. So India has attained the polio-free status. That's why we are in reach the polio-free status, but still in the around the world, as a global nature, for the two countries having the poliomyelitis, one is Afghanistan, another one is our neighbor country of Pakistan. If that country going to eradicate the disease, it's one among the second of the list under smallpox. So this is a live attenuated vaccine, MMR, varicella, and oral polio vaccine. Now I'm moving to the inactivated vaccine. Inactivator is a live organism or killed and inactivated and used as a vaccine. Yes, inactivation of the pathogenicity, inactivation of the virulence character. It is 100% heat stable and do not need the exact temperature of the storage. For example, it's a pertussis vaccine. So here you can see some of the kids' eyes. It's been reddish colors there. This is a typical pictorial for that Bordetella pertussis infection. So that kind of things we can cover with a wholesale pertussis vaccine, that is an inactivated form. And the next is a rabies vaccine. You can get much more information later in my slides. Rabies vaccine also is inactivated, and also I'll give another example. Currently, we have that whole virus inactivated against